In 2007, something impossible began happening deep inside Iran's Natanz nuclear facility. Thousands of high-speed centrifuges, vital for uranium enrichment, started failing, not just breaking, but exploding, shattering into fragments. Technicians at Natanz were baffled. They replaced thousands of their IR-1 centrifuges, only to witness the same inexplicable destruction recur again and again. This wasn't just equipment failure. It was a ghost in the machine, causing significant and costly delays to Iran's ambitious nuclear program. Then, in June 2010, halfway across the world, a small cybersecurity firm made an alarming discovery. Virus bloke Ada, based in Belarus, reported an unusually large and complex piece of malware circulating the internet, causing client computers to crash. Security researchers worldwide, spearheaded by German expert Ralph Langner, began the painstaking process of reverse engineering the malware's 500 kilobyte core. What they uncovered was unprecedented. This wasn't a generic virus, it was a highly specialized digital weapon designed with surgical precision. Stuxnet remained dormant on most systems, activating its destructive payload only when it detected specific Siemens Industrial Control Systems, or PLCs. These PLCs managed high-frequency motors, exactly the kind used to operate uranium enrichment centrifuges like those at Iran's Natanz facility. Once active, Stuxnet secretly manipulated the rotational speeds of the centrifuges, causing them to oscillate wildly between dangerously high and low frequencies. Crucially, it simultaneously fed false, normal readings back to the operators, who remained completely unaware of the physical destruction unfolding. The malware was incredibly adept at spreading, famously exploiting multiple zero-day vulnerabilities, including one that allowed it to jump networks via infected USB drives. This stealthy digital sabotage led directly to the destruction of approximately 1,000 centrifuges at Natanz, effectively crippling a significant portion of their enrichment capabilities. This was not a conventional bombing, not a missile strike. This was a silent, invisible attack that caused real-world, physical destruction without a single shot fired. But for all its precision, Stuxnet was not perfect. Despite its design for an isolated target, it unexpectedly propagated beyond its intended network. It was this unintended spread onto the open internet that led to its detection by virus bloke Ada, blowing the cover of what was clearly a nation-state operation. The world had just stumbled upon a digital weapon of mass destruction, unleashed, and then, by chance, exposed. Experts quickly concluded Stuxnet was a state-sponsored weapon, an incredible feat of engineering requiring vast resources and highly specialized knowledge. Though never officially claimed, Stuxnet is widely attributed to Operation Olympic Games, a joint cyber operation by the United States and Israel. Stuxnet revealed the world's first true digital weapon, capable of causing physical destruction in the real world without direct military engagement. It fundamentally altered the landscape of modern warfare, demonstrating that critical infrastructure could now be attacked with lines of code, not missiles. But its escape also underscored the inherent terrifying risks of deploying such powerful cyber weapons. They are notoriously difficult to control once unleashed. Stuxnet wasn't just malware, it was a stark warning. It ushered in an era where the battlefield is no longer just land, sea, or air, but the invisible realm of cyberspace. The weapon that escaped the lab proved that code can destroy, and once loose, even the most precise digital tool can become a global threat.